morning. I'm Devasena. In this lecture, we are going to discuss about satellite orbits. The satellite can be rotated around the Earth through various paths. The paths are called orbits of the satellite. These orbits are used to cover the specific application areas. Orbit fundamentals. When the satellite is moving in the orbits, it stays in position because the centripetal force on the satellite balances the gravitational attractive force of the Earth. This balance depends on the distance from the Earth, the speed of the satellite, Earth radius, and gravitational force on the Earth. The orbit of the satellite is selected on the basis of coverage area required, transmission path loss, delay time, and the period for which satellite is visible from the point of Earth. Inclined orbit. An inclined orbit is used to cover the polar regions. Here is the inclined orbit. It is not that frequently used. The height of the inclined orbit is set such that it covers the required area of the region of interest. The time for which the satellite is visible to the point on the Earth is also controlled. Satellite cannot remain in continuous contact with the point on the Earth if rotating in inclined orbit. Sometimes inclined orbit is also called elliptical orbit. Polar orbit. The polar orbit is not much suitable for communication purposes. It is used for special applications like navigational satellites. Geostationary orbit. The circular equatorial orbit is exactly in the plane of equator on the Earth. All the points on this orbit are at equal distance from Earth's surface. The satellites rotating on this orbit is most used for communication purposes. If the satellite is rotating in this orbit, has the angular velocity equal to the Earth's angular velocity, the satellite is said to be moving along the Earth. The satellite is appeared to be stationary to the point on the Earth. Therefore, this orbit is sometimes called geostationary orbit. Geosynchronous orbit. When the inclination of the orbit is not zero and or eccentricity is not zero, it is called geosynchronous orbit. The period of geosynchronous orbit is equal to period of revolution of Earth with itself. This means geostationary orbit and geosynchronous orbit have same period. Geosynchronous satellites are called as geostationary satellites. each geostationary orbit cannot be attained in practice. Hence, the term geosynchronous satellite is used instead of geostationary satellites. Now we will discuss about orbit shape, that is circular orbit we are going to discuss. For circular path, the height of satellite is the distance of satellite from Earth. But for calculation purpose, the height is the distance between center of Earth and satellite. Elliptical orbit are inclined at an angle of 64 degree with respect to equatorial plane. For elliptical path, center of Earth is one of the focal point of ellipse. Hence, the distance between Earth and the satellite varies during its revolution. Perigee and apogee. The point in the orbit where the satellite is closest to the Earth is called the perigee. The perigee is located here. And the point where the satellite is farthest from the Earth is called apogee. Here is the apogee location. The perigee and apogee distance are measured from the center of the Earth's gravitational force. Therefore, apogee and perigee include the radius of Earth. The gravitational force representation. Example, the solar system. In this solar system, due to the gravitational force, the planets revolve the sun. Thank you very much for listening this lecture. If you like this lecture means, kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.